Hello and welcome to helpyourmath.com. In this video, we are going to use the sum and difference formulas to evaluate trigonometric functions. I have the list at the bottom, so no need to memorize and worry about that I'm getting them wrong. Yay me! Okay, so in the last video, we were already given the breakdown of the friendly angles, right? So we had the nice ones with denominators of 6s or 3s or 4s. Now we're looking at degrees, so we're looking to rewrite each of these angles with some of those friendly numbers. So, the friendly numbers are 30 degrees, 45 degrees, 60 degrees, 90 degrees, and we want to be able to work with these numbers. So 75 degrees, I can write that as 30 plus 45. Yay, 30 degrees plus 45 degrees. Okay. And now we want to know what exactly is sine of 75 degrees and cosine of 75 degrees and tangent of 75 degrees. So for this, I'm using the sums. I'm going to focus on the left column of formulas because those are the sums for now I have a u of 30 degrees and a v of 45 degrees. All right, so sine of 30 degrees plus 45 degrees will be sine of 30 degrees times cosine of 45 degrees plus cosine of 30 degrees times sine of 45 degrees. All right, let's evaluate each one. Cosine of 30 degrees, that's 1/2, times cosine of 45 degrees is root 2 over 2. This ultimately becomes, well, I guess I'm going to have to really make space here, so I'm going to just keep working left and right. Cosine of 30 degrees is root 3 over 2. And sine of 45 degrees is root 2 over 2. So my first term, I get root 2 over 4 plus root 6 over 4. And as we've seen before, I can write this as one fraction, but I can't actually add root 2 plus root 6. So somewhere I'm going to go off to the side. Maybe I'm just going to try to squeeze it in down here. And I'm going to say sine of 75 degrees is root 2 plus root 6 over 4. Okay, first one done. And let's look at cosine of 75 degrees, keeping u is 30 degrees and v is 45 degrees. I'm going to say that cosine of 30 degrees plus 45 degrees is going to be cosine of 30 degrees times cosine of 45 degrees. After doing all of these, we're really going to know these values, right? So if you didn't already know them, by the end of these videos, you're going to be a pro. And sine of 45 degrees. Okay, cosine of 30 degrees will be root 3 over 2. Cosine of 45 degrees is root 2 over 2. Minus sine of 30 degrees is 1/2 times sine of 45 degrees is root 2 over 2. And we get root 6 over 4 minus root 2 over 4. So very similar radicals here, right? We're going to say that cosine of 75 degrees this would be root 6 minus root 2, all divided by 4. Keeping in mind, we don't have like radicals, so we have to leave them separate. And last, for this first example, we have tangent of 75 degrees. Again, I'm going to keep the u and the v the same. And we're going to say tangent of 30 degrees plus 45 degrees will be, first time seeing tangent of 30 degrees plus tangent of 45 degrees, all divided by 1 minus tangent of 30 degrees plus tangent of 45 degrees. And let's see what happens when we simplify each of these. Tangent of 30 degrees, that is root 3 over 3 plus, 1. That's nice, kind of. And then in the denominator, we have 1 minus tangent of 30 degrees, root 3. Oh, did I say plus here? That should be a times sign, shouldn't it? Times, 3 over 3 times 1. Oh boy, okay. Then simplifying this one a little bit further. So I have complex fractions. I'm going to just get the same denominator in the numerator, where 1 over 1, I'm going to multiply by 3 over 3, so I get root 3 plus 3 over 3. And I'll do the same thing in the denominator, where I'm going to have 3 minus root 3 over 3. ooh, those denominators of 3 cancel. And it looks really tempting, like I could simplify or do something, but I actually can't because I have root 3 plus 3 in the numerator and 3 minus root 3 in the denominator. And that would be my final very awkward expression. So I'm going to try to squeeze that in the bottom of the screen here. Where we have tangent of 75 degrees equals, I can make this a little bit nicer and just say 3 plus root 3 divided by 3 minus root 3. I had to kind of shift it because the controls are down there, but that should just be a fraction on top of itself. So they're actually conjugates, which is kind of cute. Okay, and then up next we have 105 degrees, and I've got a lot less space to work with, so we're really going to squish this one in. We need to figure out how can I create 105 degrees using any of these available options. Now, I wrote down 4 of them at the top, 30, 45, 60, and 90. But remember, we could also subtract. So if I could think of something more than 105, and then I could take away something, that's really up to you. I think I can already see that it's 45 plus 60. So since I already see that, I'm going to use that. But if you find another friendly one, you could use the difference formulas as well. Okay, so I'm thinking about 105 degrees as 45 degrees plus 60 degrees. And again, I'm going to apply these sum formulas where I have u is 45 degrees and v is 60 degrees. Starting off calculating sine of 105 will be sine of 45 degrees plus 60 degrees, where we're going to get sine of 45 degrees times cosine of 60 degrees plus cosine of 45 degrees, oh, it's not going to fit, times sine of 60 degrees. I'll stop using parentheses, save space. Okay, sine of 45 degrees is root 2 over 2, times cosine of 60 degrees is 1/2, plus cosine of 45 degrees is root 2 over 2, and sine of 60 is root 3 over 2. And we'll simplify this, clean this up a little bit. We get root 2 over 4 plus root 6 over 4. Oh, very similar to our sine of 75 degrees. Awkward. I'm just kidding. It's not awkward. It's fine. It's great. And we'll put our final answer down here. Maybe. There we go. We're going to say, let's see if we can squish it in, sine of 105 degrees is also sine of 75 degrees, or we could say root 2 plus root 6 divided by 4. Next up, we have cosine of 105 degrees, cosine of 45 degrees plus 60 degrees, and we get cosine of 45 degrees. Oh, remember I was going to stop using parentheses, and here I go using them again. Times cosine of 60 degrees minus sine of 45 degrees times sine of 60 degrees. Oh, barely squished it in there. Yay. Okay. And cosine of 45 degrees is root 2 over 2 times cosine of 60 degrees is 1/2 minus sine of 45 degrees, root 2 over 2 times sine of 60, which is root 3 over 2. And so this ends up becoming, I'm just going to write it down here because I don't think we're going to be able to simplify it. We're going to say that cosine of 105 degrees is, it's backwards of the cosine of 75 degrees. We get root 2 minus root 6, all divided by 4. So we're starting to see a little bit of a difference, which is good, right? They shouldn't be identical. And last up, I'm going to use the dark blue to evaluate tangent of 105 degrees. Tangent's going to be our big fraction. We're going to do tangent of 45 degrees plus tangent of 60 degrees, and we're going to get tangent of 45 degrees plus tangent of 60 degrees divided by 1 minus tangent of 45 degrees times tangent of 60 degrees. And what does that give us? Tangent of 45 degrees is 1. Tangent of 60 degrees is root 3. No complex fraction this time. And then in the denominator, we have 1 minus, this is a 1, and this again is a root 3. Oh, so we do end up with those conjugates again. And we'll write our final answer. We'll try to squish it in down here. Tangent of 105 degrees we get to be 1 plus the square root of 3 over its conjugate 1 minus square root of 3. And that would be using the sum formulas to evaluate all these different trigonometric ratios. And now we're going to do it all over again, right? So this time we have 2 more examples. This time they're both in radians. And let's see what ends up happening with these. So keeping in mind the friendly radian values, I can tell by the negative that we're going to want to keep 0 radians in mind. There's also pi over 3, pi over 4, pi over 6. These are backwards. It should be pi over 6s, but that's okay. I'm not putting these in any particular order. We'll throw a pi over 2 in here and anything else that makes sense. So I think for negative pi over 12, I'm looking at, does this equal pi over 4 minus pi over 3? Let's do that math. So the common denominator here is 12. That's 3 pi over 12 minus 4 pi over 12. Yeah, so that's what we want to use. Oh, look, a difference. So I'm going to use pi over 4 and pi over 3. Pi over 4 will be my u, and my v will be pi over 3 as we apply our difference formulas. So a different set of i's on this one. Starting off with sine of negative pi over 12. That's going to be sine of pi over 4 minus pi over 3. Well, we're going to get sine of pi over 4 times cosine of pi over 3 minus cosine of pi over 4 times sine of pi over 3. And sine of pi over 4, that's going to be root 2 over 2. Cosine of pi over 3 is 1/2 minus cosine of pi over 4 is root 2 over 2 times sine of pi over 3, which is root 3 over 2. When I look at these, that's root 2 over 4 minus root 6 over 4. So another one with using these root 2s and root 6 is very popular. And that would be, and then I'm just going to write it as one fraction, but I'll put my final answers down here. So sine of negative pi over 12 is going to equal root 2 minus root 6 all divided by 4. Next up, we have cosine of negative pi over 12, which will be cosine of pi over 4 minus pi over 3. And when we set up cosine, we have cosine of pi over 4 times cosine of pi over 3 plus sine of pi over 4 times sine of pi over 3. And when we evaluate these, we get root 2 over 2 times 1/2 plus root 2 over 2 times root 3 over 2. And that's going to give us root 2 over 4 plus root 6 over 4, which I will just simplify as I get down to the bottom of this. So we're going to say cosine of negative pi over 12 equals root 2 plus root 6 all divided by 4. Looking good so far? I think so. And, you know, as I'm going through this, I kept it as negative pi over 12, but if you wanted to, you could find the coterminal angle that's positive where you don't have to use subtraction. Trig is so beautiful in that there's so many things that just overlap, so many overlapping ideas that, you know, you can really make it as friendly as you want. But I just kept it as is because I can. Why not? Last up, we have tangent of pi over 4 minus pi over 3. And so we're going to say we have tangent of pi over 4 minus tangent of pi over 3 divided by 1 plus tangent of pi over 4 times tangent of pi over 3. And when we simplify these tangents, tangent of pi over 4 is 1 minus tangent of pi over 3 is root 3 over 1 plus 1 times root 3. And so again, we get those conjugates, always the conjugates. And we'll add this one to my answers down here, where we're going to say tangent of negative pi over 12 equals 1 minus root 3 divided by, all right, it wasn't pretty, but I did squeeze it in. So we have 1 minus root 3 over 1 plus root 3. And again, no simplifying can be done there because they are conjugates, and that's not much we can do. All right, last example, we have 11 pi over 12. How can we make 11 pi over 12? Oh, goodness. So our last example, we have to get a little creative because we need to be able to use these friendly numbers, these friendly radian measures, to give us 11 pi over 12. So what I'm thinking is that maybe we can use 3 pi over 4, because 3 pi over 4, if we put it with a denominator of 12, that would be times 3, is 9 pi over 12. And now what I need, because I need 11 pi, I need 2 pi over 12 more. Where can I get 2 pi over 12? Oh, isn't that just pi over 6, right? Then I can say pi over 6 is 2 pi over 12. So these are the ones that I want to use. This is addition, so I will be using the sum formulas one more time. So we're going to say that 11 pi over 12 is 3 pi over 4 plus pi over 6. That's going to be our u and our v. Again, I had to get a little creative there. And if you want, because of the flexibility of trigonometry, if it's easier for you, convert it into degrees. And then you can just work with the degree measures. Maybe you'll find that to be a little friendlier. I like to, when I see the example, I'm going to keep it as is, but that's just me. You are welcome to change it and adapt it so that you feel more comfortable with this. Because, converting these denominators and using fractions that aren't in quadrant 1, it can be weird. Okay, so we're thinking about 11 pi over 12 as 3 pi over 4 plus pi over 6. All right, so let's find the exact value of sine of 11 pi over 12. We're going to say sine of 3 pi over 4 plus pi over 6 is equal to sine of 3 pi over 4 times cosine of pi over 6 plus cosine of 3 pi over 4 times sine of pi over 6. And what that's going to give us, we're going to get sine of 3 pi over 4. 3 pi over 4 terminates in quadrant 2 where sine is positive. We're going to get root 2 over 2 times cosine of pi over 6 is root 3 over 2 plus, and now we have cosine of 3 pi over 4. Cosine is negative in quadrant 2, so this ends up being negative root 2 over 2. And sine of pi over 6 is 1/2. Cleaning this all up, I'm going to work up to try to save some space so I'm not super squished. We get root 6 over 4 minus root 2 over 4. Okay, so one of those normal ones that we get a lot. And we're going to say that sine of 11 pi over 12 is equal to root 6 minus root 2 all over 4. Next up, we're going to evaluate cosine of 11 pi over 12 by actually evaluating cosine of 3 pi over 4 plus plus pi over 6. 11's what's given, of course. Okay, so cosine, we're going to say cosine of 3 pi over 4 times cosine of pi over 6 minus sine of 3 pi over 4. Let's try that again. That's better. 3 pi over 4 times sine of pi over 6. And what do we get? Well, we get cosine of 3 pi over 4. We just did that right up here, right? So it does get repetitive as we do this, which is nice. We can just use those same values. Cosine of pi over 6 is root 3 over 2 minus sine of 3 pi over 4, we know is positive root 2 over 2 times sine of pi over 6, which is 1/2. And so I'm going to just try to squish it in down here. We're going to say cosine of 11 pi over 12 is equal to, we get negative root 6 minus root 2 all divided by 4. And last but not least is our friend tangent. We want to know tangent of 11 pi over 12, which we're going to figure out via tangent of 3 pi over 4 plus pi over 6. And that's going to give us tangent of 3 pi over 4 plus tangent of pi over 6 divided by 1 minus tangent of 3 pi over 4 times tangent of pi over 6. And tangent of 3 pi over 4, tangent is negative in quadrant 2, so we will get negative 1 plus tangent of pi over 6 is root 3 over 3. So we will have a complex fraction. We'll address that as needed. In the denominator, we have 1 minus tangent of 3 pi over 4, we said was negative 1. And then tangent of pi over 6, we said was root 3 over 3. Okay, so in the numerator, we do have to do a little bit of trickery because we want to be able to combine these. We don't want a complex fraction. Negative 1 is negative 3 over 3. And so now I can combine, I can say negative 3 plus root 3 all over that common denominator of 3 divided by, and then again, 1 will be 3 over 3. This minus negative becomes plus root 3 over 3. These 3's, the denominators, because everything's a 3, but the denominator 3's cancel. And we do have those that conjugate pair again, although it's like in reverse. And we can say that tangent of 11 pi over 12 is equal to negative 3 plus root 3 over 3 plus root 3. This has been several examples of how we can use the sum and difference formulas of these trigonometric ratios. Thank you for stopping by.